moving on to our next section, it's going to be a product launch. And we have two dynamic leaders from the industry are here who is going to do this product launch. Our first leader in the screen, you can see Sambit Sahu. Sambit Sahu is the Vice President of the IoT Group and the General Manager of High Velocity Silicon and the Platform Engineering Group across the globe at Intel Corporation. Based in Bangalore, he leads the product design and the development operations, IoT market segments, with a focus on promoting excellence in system on chip and the platform design. With over 20 years of experience in the semiconductor industry, Mr. Sahu has held a number of technical and management leadership positions in multiple areas of SoC design. Throughout his career, he has led the teams in delivering dozens of products in the various market segments, including smartphone, modem, IoT devices, small cell product, and intelligent routers. Before rejoining Intel in 2016, Sambit spent 4 years in Qualcomm, culminating his role as a vice president of engineering at Qualcomm Bangalore Design Center. He joined Qualcomm from Intel India, where he held a leadership position in the server development group from 2005 to 2012. Earlier in his career, Sambit spent 13 years of working in United States, where he served as a senior technical staff roles and Sun Microsystem, then Rocket Networks also. He started his career in 1992 in Intel, spending his first 8 years with the company as a technical lead and manager in the intellectual property development and the electronic design automation or EDA roles. Sahu earned his bachelor's degree in the electronics and telecommunication engineering from University College of Engineering, Baroda, India, and a master degree in the computer engineering from University of Louisiana at Lafayette. So it's our great honor and great privilege to get Sambit on stage today. And along with Sambit, we have Sanjeev Khushu. Sanjeev is the Vice President of Technology and Architecture in IoT Group at Intel. Sanjeev created the concept of the Lakefield product and led the project. Before Intel, Sanjeev spent a number of years in Qualcomm San Diego, where, among many things, he led an initiative to build the first sub $50 LTE smartphone of the world for India, China, and other markets in Asia. So it's my great honor and privilege to invite Sambit and Sanjeev on stage, and they will introduce the product Lakefield from here on. Welcome.
Thank you, Sumit. Thank you, Sumit, for the kind introduction. Good morning, good afternoon, good evening, everyone. Hope all of you are doing well and hope all of you are staying safe. I'm joined by with my esteemed colleague Sanjeev. Actually, Sanjeev deserves pretty much all the credit for Lakefield. I'm glad to share the stage with him. And uh, so, Sumit, are the slides being presented?
Yes.
Okay.
Yes, Amit, I'm gonna share the slides. Please guide me when to change the slide. I'm gonna share.
Yeah, please go to the next slide. I'm not able to see the slide somehow. Okay, great. Thank you. Thank you, Sumit. And just would like to state the legal disclaimers. And next slide, please. So Lakefield is a very novel processor design that we have been working for last few years. And we are proud to say it was launched earlier this year. And post the launch, a couple of big OEMs like Samsung and Lenovo announced their products with Lakefield. And our objective of Lakefield was to really find the sweet spot, taking advantage of PCs, the performance advantage, as well as the Windows compatibility of the PCs on one side, and the long battery life and the thin and small form factors of smartphone on the other side. So we wanted to design on the sweet spot of that PC goodness as well as smartphone goodness. And while doing so, we went through lots and lots of technology breakthroughs and lots of wonderful ideas. And Sanjeev will share a lot of that. And finally, we could deliver this product. And not only this product is now out in the market, but a lot of the concepts and technologies that we built in Lakefield is now a de facto in many future Intel products. And a lot of engineers actually they say that Lakefield is a engineer's paradise. The amount of innovation, technology breakthroughs that went into it. Pretty complex device because the challenges are very significant. Taking the species into thin form factors and long battery life was not easy, as well as taking the smartphone concepts into performance also not easy. So delivered 4 dies in a very disaggregated manner on 3 tech nodes to take advantage of the power performance trade-offs. A lot of multiple new IPs were developed, and we could pack 5 billion transistors in these 4 dies in a very small form factor and 215 megabits of memory. And this product, the design of it was led by Intel India, and we assembled people from processor expertise and industry ASIC expertise. To do this product, we needed both expertise. So very quickly, we assembled a pretty significant and talented team from the processor world as well as the ASIC world to do this. And of course, great collaboration with teams worldwide. A lot of engineers from different countries contributed and helped in delivering this product. And in the process, we also established a very strong ecosystem with the IDEA partners, IP partners, consultants, because we had to develop a lot of new methodologies, a lot of new flows, bring out a lot of new IPs. So I'm proud to say that we really developed the ecosystem during the process. And in the process, we also established a very transformational HVDM system to bring the best of methodologies and practices from the processor world and blend it with the best of practices in the ASIC and the mobile world. And we came up with recipes and flows and methodologies that will help us do such designs in the future. And all these concepts I see is going to feed into the next technology revolution in the form of IoT and AI products because they need high performance and on one side, but also they'll need long battery life and thin form factors, so different applications. So a lot of the technology we developed are becoming key foundation of the future IoT and AI products. With that, I will hand over to Sanjeev to talk about a lot of the technology marvels that was done in this product. Sanjeev, please proceed.
Thank you. Hopefully you can all hear me okay. Thank you, Sumit. Thank you, Sambit. Good morning, good evening. Thank you all for joining in. I'm Sanjeev Khushu. I'm calling from California. So it's a little past midnight for me. Hopefully I can stay awake for the remaining 15 minutes that I have. First, just a quick background about Lakefield, right? A few years back at Intel, we had a requirement to enable a new type of devices, a device with a PC-like compute in a mobility form factor. Devices which are thin, lightweight, but have a long standby time without compromising on performance. So we need a substantial reduction in board area and power, but at the same time, a significant gain in performance. So, but in silicon design, you typically follow a certain gen over gen CAGR, maybe a 10 to 20% power and performance improvement with process node migration and architecture improvements. But our requirement for Lakefield were way outside of the 20% range. So we certainly had to migrate to the latest Intel 10 nanometer process and latest generation IPs for compute like CPU and graphics and media and display. But we also had to do something else, something fundamentally different to get anything close to what the requirements were for Lakefield. So the numbers you see on the charts represent gen over gen improvements on Lakefield. So we reduced our package size by 56% compared to the previous generation. Or we reduced our standby power by 91%. Our single-threaded ST performance went up by 12%. Our power efficiency increased by 24%. And at the same time, our graphics performance was 1.7x compared to previous generation. And our throughput for AI workloads was 2x, all within the smallest client compute processor that Intel has ever built. Next slide. Yeah, the improvements I shared in the previous slide were made possible by a number of initiatives in silicon and platform design. So there were more than 20 new initiatives that were introduced in Lakefield, but out of those, there were two which were sort of pivotal, something fundamental to Lakefield design, without which the scale of improvements were not possible in Lakefield. So first is Foveros. It's a technology that gives us a flexibility to stack dies into three-dimensional space instead of a traditional two-dimensional monolithic design. It's a concept maybe some of you can possibly easily relate to. In a real estate world, as land gets more expensive, what do? The builders go up, they make multi-story buildings. It's just that in silicon design, it was never done before, and it's a lot more complicated than making buildings. So this 3D stacking allowed us to build Lakefield in a 12 by 12 millimeter package, the smallest PC compute, like I said, ever built in the industry. So you can see these XY dimensions in smartphones, but even in smartphones, like 12 by 12 is considered to be small. The second pillar is hybrid compute. So up until Lakefield, in IS Silicon, you will either see a big performance cores together, or you will see Atom CPUs, which are power efficient cores. So in Lakefield, for the first time, we combined the big core, in our case was Sunnycove, and 4 Atom cores, which are Tremont cores, together in one single design. I do have a little more details on the following slides, but these two technology initiatives were fundamental to Lakefield design, both being introduced for the first time. So we recently announced follow-on products with both Foveros and hybrid technologies. So we are carrying forward these initiatives into future products at Intel, like Sambit mentioned. Go to the next slide. Yeah, so this slide gives a little bit of background about Foveros and advanced packaging. The chart is just for illustration. So on the x-axis, it indicates power, and y, it's performance. So what it shows is that there's a tremendous amount of variance in the kind of transistors that we need to build to address all the aspects of compute you have these days, right? I mean, on one side, you have desktop CPUs, where it needs high performance and it can afford high power. But on the other side, we have mobile CPUs, you have iGPUs that need lower power. So the point is, no single transistor node is optimal across all design points. So what is the answer? The answer to the problem is build them separately. So you build CPUs in one process and then take all the advantages that the latest process technology can offer you, and build IOs in a different process with latest process technology is not required, and or even build graphics in a different process. And then you kind of combine them together using advanced packaging techniques to make it behave like a monolithic design. So Foveros development model also allows you sort of build IPs or dies to build separately, and then you kind of test them and develop them separately and put them together to save costs and time to market and bring all the advantages that come along with die disaggregation. And that's kind of what we did in Lakefield. We built all the compute-centric IPs in latest 10 nanometer process while building the IOs in a different process node, and then we combined them together and stacking the dies on top of each other. Go to the next slide. Yeah, this picture shows you inside view of Lakefield with Foveros, like an ultra small, as I said, 12 by 12 by 1 package, starting with a base die in the bottom, which includes the IOs, the low power logic, the power delivery in P1222 process. On top of that, we have a compute die with all compute IPs in 10 nanometer process, your graphics, your media, your displays. And we have a high bandwidth, ultra low power die-to-die connection, and a thermal solution to optimize any thermal dissipation that comes along with when you stack the dies together. And top of that, we have a POP memory, which comes in two options for Lakefield. We have a 4 GB and an 8 GB option. In Lakefield, we chose to go with POP memory, but conceptually, memory can be discrete as well. And in fact, it becomes necessary as we go into higher thermal envelopes where you go with discrete memory and not POP memory. You can go to the next slide. So now I'm going to talk a little bit about the second important pillar of Lakefield, which is hybrid compute. So traditionally in the industry, like smartphones, for example, there is this concept of heterogeneous compute where you combine small power efficient cores and big CPU cores together. In Lakefield, what we did is what we call is big and bigger together. We took the big atom cores, the power efficient cores, and we combined them with Cinecope cores. So a combination of hardware and software with hardware guided scheduler, we have an ability to dynamically decide which core to use for what workloads. So the threads which are performance centric and need to have quick responsiveness get scheduled on a big core, while the threads which are not performance centric get scheduled in atom cores. So all the 5 cores execute applications and threads concurrently. So if you click on a browser, the big performance core should kick in to ensure the launch time is optimal, and for any background activity like virus scan or email can run on these power efficient atom cores. So as a result of this configuration, we take the best of 2 options that IA has to offer, get the best possible performance, but at the same time optimize for battery life. With this architecture, we're able to achieve up to 33% better web performance and 17% higher power efficiency. Next slide. This is my last slide. So a little bit about the end products, like Sambit said earlier. So both Intel and Samsung recently announced the launch of Galaxy Book S in June of 2020, Lakefield, and this device is already available in store. We also Lenovo X1 Fold launch coming up shortly, which is planned for second half of 2020. And that's pretty much what I had. Thank you.
Okay, thank you. Thanks, Sanjeev and Sambit, for this wonderful introduction of this particular topic. And you could see that there are a lot of good technologies embedded in here to make it a reality. So thanks for introducing the product and the insight of the product. Inside technologies over there, and I can see a lot of next generation technologies are embedded. So I know it is pretty late for you. So we are also running a little behind on time in this conference, so not holding you further up. Please give a big round of applause for Sanjeev and Sambit for this excellent presentation.
Thank you.
Thank you, Sumit. Thank you, everyone.
So with that, we are now moving on to our next segment of the presentation, next segment of the conference. And this time we'll be focusing on to the communication side of the things. So we have an eminent set of panelists here, and this panelist is going to talk about how is the for the processor, how is the communication is going. This. All right, I can see them. There was some noise on the line. Can you okay, so all right, there is some, looks like some noise in the line. Nathan, can you please check? Okay, so this is my great honor to introduce our next set of speakers. And this is going to be a theme session and which will be focusing 5G and beyond. So our first speaker is going to be Miss Aruna Sundarajan. So Miss Sundarajan is a 1982 batch of Kerala cadre officers of Indian Administrative Services. She superannuated in the 31st July 2019 as a chairman of the Digital Communication Commission and the Secretary Government of India. As Secretary of DOT, she was the chief architect of the National Digital Communication Policy in 2018, which aims to propel India as a global leader in the digital communications. Key achievements during her tenure was the launch of country's 5G roadmap, establishment of the indigenous test bed, launch of the National Frequency Allocation Plan in 2018, and the completion of the first phase of BharatNet. Additionally, her tenure saw the biggest wave of consolidation and the mergers in the telecom industry, including the largest M&A in India, a virtual tripling of the telecom infrastructure, and the massive expansion of the activities of the USOF to cover the uncovered areas and the promotional initiatives for startups in the telecom sector. Prior to this, she served as a Secretary, Minister of Electronics and Information Technology, which we popularly call as MITI, where she drove the Digital India initiatives, particularly during the post-demonetization phase. During her tenure, she was instrumental in establishing India as a major hub of electronics, particularly in the mobile manufacturing, launch of the VMAP and the campaign for the digital payments, use of Aadhaar as a DBT, enhancing India's role in internet governance, and establishing the National Cyber Control Center or NCCC for the cyber security. So it is great honor to have you, ma'am, over here, and you will be chairing the session. And let me quickly introduce the other panelists over here. We have, along with us, we have Mr. Sanjay Naik. Sanjay is the CEO and MD of Tejas Network. Sanjay has several years of experience in the field of telecommunication and networking. Prior to Tejas Network, Sanjay was the managing director of Synopsys India Private Limited. Sanjay received the Techno Innovation Sarabhai Award from India Electronics and Semiconductor Association and the Electronic Man of the Year from ESCINA in 2011. He is the co-chairman of Indian Telecom Equipment and the Services Export Promotion Council, which is TPEC, and was a member in the CII's National Committee for ICTE in the year 2017. So welcome Sanjay to the panel. Our next panelist is going to be the Rajesh Nambiar. Rajesh Nambiar serves as the chairman and the president of Sienna India. In this role, he is responsible for driving Sienna continued success and the growth in the country. Rajesh helps in guide local customers and partners on their networking transformation journey, gives Sienna a voice within government and the industry association, and leads the Sienna India's growing employee base. Previously, Rajesh was the general manager and the global leader of IBM $8 billion application services business, which built and managed software applications for the clients worldwide. While based in Singapore, he was the managing partner for the global business services in IBM for the Southeast Asia, and also he led the consulting and application services business across 6 different countries. Rajesh holds a master degree in statistics from Indian Statistical Institute and the advanced management degree from the Harvard Business School. So welcome Rajesh to the panel. And the final panelist on the panel was Mr. Parag Naik. Parag is a technology serial entrepreneur with more than 26 years of industry experience, out of which 18 years have been in the indigenous high technology startups. Right now, he is the CEO of Sankha Labs. At Sankha, he has been the CEO since April 2014. He co-founded Sankha and was the CTO and the VP marketing between 2007 to 2014, contributing to the product roadmap and designing the award-winning Sankha SDR architecture. Sankha is India's first private fabless semiconductor company. Prior to Sankha, he co-founded Smart Yantra Technologies in 2000 and Vyavya Labs, India's first electronic design automation company in 2006. Smart Yantra was acquired by Genesis Microchip in 2004. Early on his career, he worked on a mission for the computer hardware and the software for the India's indigenous LCA Tejas and at Philips Innovation Lab as one of its early members building world early DTV and STP drivers. So welcome Parag on that. And with that introduction, I would like to hand over the stage to the session chair, which is Ms. Aruna Sundarajan. Ma'am, over to you.
Thank you, Sumit, for that introduction. I hope I'm audible, first of all.
Yes.
Yes, ma'am, we can hear you loud and clear.
Yeah. So I think since we are running late and we have 3 excellent panelists, I am not going to take too much time except to make a few opening remarks, which I think are relevant in this context. Before the advent of Corona, we used to often say that the world is at the cusp of a paradigmatic shift, which 5G is going to usher in. I think that paradigmatic shift just got accelerated a whole lot with COVID coming in. And if there is one thing that this pandemic has really brought home to all of us, it is that digital communications is going to be at the heart of the new paradigm post-COVID. Having said that, We also know that there has been a sea change in the landscape. Even when the government of India brought out the roadmap on 5G, it was still largely business as usual, with reliance on a few hardware vendors who were already at the forefront of 5G. But I think much has happened. Today, virtually every country in the world is rethinking its strategy on 5G. It's reviewing its own capabilities. Is trying to see, how each country can safeguard itself because security has become so paramount. So in this scenario, I think it's going to be very interesting to hear from three industry leaders on what is their perspective, of how India goes about building its 5G capability. What is self-reliance going to mean in this increasingly interdependent world? What should the government of India be doing, and how do we all come together to collaborate to deliver the kind of 5G network that the country and the economy and society need? So with these few words, I will first request Rajesh Nambiar to present his opening remarks and his presentation. And then we will follow it up with Sanjay Naik, and Parag will then go after that. So with this, let me hand over to Rajesh Nambiar.
All right. Thank you very much. Like there's a bit of noise somewhere. You can hear me well? All right.
Yes, Rajesh, we can hear you.
Perfect. Thank you. So as we all know that there's been today, especially, there's been a lot of discussions around 5G, especially, and its use cases. And Aruna, you just spoke about the criticality of digital communication, right? But there's one thing probably less discussed in today's world is the increasing complexity of the network itself, especially with 5G and the way to manage this. And I thought we'll spend a few minutes on this aspect of this, and we all know that look, Indian telecom industry is full of activities, and you may or may not be a lot of money involved, but I think that the market is surging quite a bit, and we are currently the world's second largest telecom market with a subscriber base of over 1 billion subscribers. Video, gaming, cloud services, IoT, you name it, right? Many other trends have emerged in the recent years, bringing both clearly new opportunities as well as, of course, new challenges for the network providers. So I want to start with the premise that because of this huge change in the consumption pattern, our networks will have to be fundamentally change and be more adaptive. If you move to the next slide, there's an explosion in network demand, right? Driven by clearly the ultra mobile users who want the ability to access the cloud and consume high definition content, be it video or applications or whatever they choose to use, and whenever they choose to use, right? So that's the whole point. And the current lockdown, of course, due to this pandemic, has actually accelerated this even more, with whether it's work from home or video conferences or telemedicine and remote education and whatnot. So, and users want a certain quality of service, quality of experience with their network interactions, and network themselves are poised for a sea change, right? Legacy infrastructure and traditional data centers, whatever we had in architecture point of view, are certainly not sufficient to meet the demand of today's digital users and digital businesses, right? So this transformation requires agility and velocity that far outstrips the classical architecture and practices. If you move to the next slide, and we see that consumers today are relying more on mobile devices than ever before, whether the apps like whether Netflix or WhatsApp and Hotstar and what have you, they've all gained massive widespread popularity. So consumers want more from their operators, but they're not necessarily willing to pay more, though, right? So this is driving the need for the service providers or telcos to continually lower their cost structure, reduce operating expense, but accelerate time to revenue and launch and retire services at unprecedented speeds, right? We have never seen this in the past. But in the meanwhile, end customers' perception of value has also shifted from connectivity to an overall quality of experience that we talked about. So this has increased pressure on incumbent service providers to deliver a faster time to market and a much higher quality of experience, right, at a much lower cost. If we move to the next slide, and if you look at what is happening within the networking space, so we would look at live streaming of a mega rock star, for instance, right, which is now gaining a lot of popularity, and it's applying more and more pressure on the network. How does the network process that much demand while millions of devices are put into unprecedented pressure on the network? That's quite literally under spotlight. So if you move to the next slide. And a very, very similar context to what we saw before when we consider esports, for instance, right? Competitive multiplayer electronic games played by professional athletes, right? I mean, these are real professional athletes playing on virtually for substantial cash prizes. So the tournaments like ESL1, for example, attract thousands of spectators and millions of fans streaming that event live, actually. So e-gaming is the new buzzword, and the global gaming market, for those of you who are not following that, is growing rapidly, with gamers spending an estimated $152 billion in 2019 alone. So this eclipses, and clearly eclipses all the markets for other forms of entertainment, such as film, for example, just a $43 billion industry, and music is about $22 billion industry or so. So the gaming market also continues to grow twice at the rate of film or music. So 10% for gaming, versus 5 or 4% for film and music. So in short, gaming is a huge business, and we need to pay attention to that. A network could literally mean the difference between someone winning or losing in the e-games, right? And here is where the proverbial URLLC they talk about ultra reliable low latency communications of 5G will make a huge impact. And if you move to the next slide, so globally as well as in India, in India's networking space has evolved extremely rapidly, right? I mean, so video, cloud gaming, services around cloud, 5G, IoT, and many other exciting trends, as we spoke before, are all lacing out new promises for the network providers. And then top it all, tech giants, whether it is all of the web scalers, whether it's Google, Facebook, Microsoft, etc., investing and collaborating with the telecom operators. We saw all the new deals happening in the market of late. And cloud players are offering whole bouquet of services, whether it is software as a service, infrastructure as a service, platform as a service, and so on. So there is a huge surge in the demand on the network, whether it is for entertainment, education, health, or working from home. It's disrupting the way networks have been operating till now. We move to the next slide. And we all know that old systems can't handle new demands. So most of today's networks are full of legacy systems, legacy billing models, and surely using legacy protocols, because as there is a lot of revenue still available in the established services. But all of these make the networks very bloated and very slow, to be honest, and with tens and or hundreds of manual processes involved in setup, revision, and teardown. So many companies are still using spreadsheets and offline tools when the new service is requested. And this can take a very, very long time. So if you move to the next slide. So in my mind, the challenge in many of today's network, if you go to the next slide, please, supporting the growth rely on manual process to set up, and not only for setting it up, but also to modify and deactivate even the simplest services. The manual nature of these processes, means that they can't scale with the current rapid pace of growth. So in the interest of time, I'm going to go a little faster and let's get to the solution. So let's go to the solution. If you go to the next slide, yeah, that's good. So So what's our solution? So we talked about the problem. So to overcome these challenges we discussed so far, telecom operators should be able to adapt to these changing customer demands while enhancing customer experience. We talked about quality of experience before, but this they can do by advancing their network over time to be more responsive, automated, and agile. Right. So this is an architecture vision within CNI. We call it adaptive network. So the adaptive network is the ideal network. It should be the ideal network end state in some sense that utilizes automation guided by analytics and intent-based policies to rapidly scale, self-configure, self-optimize, and by constantly assessing network pressures and demands. So what are we talking about? We're talking about a network which is fundamentally has got three components. The first one being programmable infrastructure, which is the connect piece of it. So a very highly instrumented programmable infrastructure that can be accessed and configured via common open infrastructure. So that's the first one. Second one on top of that would be analytics and intelligence. So basically, first was about connecting. This is about sensing. How do you, collecting network performance data and analyzing this using artificial intelligence, providing the ability to be more accurately predict potential network problems and anticipate trends by turning mountains of data into very, very actionable insights. So once you have these insights, then the third layer, which is the software control and automation, which is where you're going to be act on some of this, whether it is multi-domain service orchestration, federated inventory, and centralized software-defined control of all individual domains, as well as it's very critical to adaptive networking, right? Again, as I said, in the interest of time, we are already late, so I'm going to sort of wrap this up, and then we can have much more broader conversations. So if you move to my last slide, I want to summarize by saying users ever increasing expectations and the technology breakthroughs that continue to feed them, right, have created this unprecedented level of pressure and complexity for today's network providers. So some strategic approaches suggest that to manage this level of complexity, a fully automated network is essential. So we need to take a broader view, believing that a network, just like us, the human beings who invented it in the first place, must grow smarter and more agile and more responsive every single day. So therefore, network providers must strive to get closer and closer and then maybe achieve this adaptive network model that we talked about. So let me stop there, Aruna, and I know that we are running short of time, so I don't want to belabor it, but we can get back into the Q&A later on.
Yeah, thank you, Rajesh. That was absolutely fascinating, telling us what the networks of tomorrow need to look like. So with that, let me hand over to you, Sanjay, because I think you are one of the few people who, along with your team, has actually built a product company in this telecom segment. So we're very interested to hear from you.
Thank you, Aruna. First of all, it's always good to be at IESA event. In fact, I used to be on the executive council during the year when we changed the name of ISA to IESA. So a lot of friends in the industry, and always glad to be here. So what I'm going to be talking about in the next 5 to 7 minutes is 5G and beyond, and really in the relevance of the conference, self-reliance in telecom equipment and communication silicon. What can India do about it? So can you please go to the next slide? So I said, well, let's answer 4 key questions. Number 1, is it important for India to build a domestic telecom product ecosystem? And I really believe the title of the talk today was 5G and beyond. Actually, it should be 4G and beyond, because 4G is still available here. A lot needs to get done. And what will be beyond 5G, which is 6G, even the 3GPP hasn't come out. So maybe in 2030, we might have a 6G. So really, it should be 4G and beyond. Second question we need to answer is, how soon do we need 5G in India? What are the use cases? Does India really need to have 5G just for the bragging rights, or do we really need 5G as a country? That's the second question. The third question is, do we have the capabilities to build an indigenous telecom product and silicon ecosystem in the country? And assuming we do, how do we do it? How long will it take? Can we afford to wait? and what role does the government need to play? So in the next 4 slides, and I won't take more, I would go through one by one for each of these 4 questions. I really believe self-reliance in telecom equipment is a necessity. As Aruna ma'am had mentioned today, and I attended Paul Raj's presentation on the first day of the conference, the communication is a strategic asset. The fact that we are having this conference in the form that we have is thanks to the robust communication infrastructure. And if India is going to be aspiring to be a top 5 global economy, self-reliance and control of this strategic asset is an absolute must. We see the national security aspects, and people are, kind of sometimes misled into believing that you need a Trojan, you need a trapdoor into hacking a telecom system. It's actually much simpler. You can just shut out the entire network with a few commands, and that's how vulnerable we are. So I think we should be very clear that security of telecom networks as an asset is absolutely number one, even probably more than a land army or physical army in that sense. And secondly, 5G will have a generational impact. It is not yet another G like 4G going to 2G going to 3G. 5G will impact across industries. I'm not going to describe that. I'm sure a lot of us have read everything about it. So this is something which is like a once in a 10-year decision, and that is the reason why you see US and all the other countries in the world seriously taking a look at how do they go about building the 5G ecosystem. Taking the strategic part apart, economics, which is very important, 5G and the whole ecosystem around will probably play a very key role in the 5 trillion economy mission that we have. Probably on a first cut rule of thumb estimate, at least a $500 billion impact. We'll save about $100 billion worth of foreign exchange if you can do a domestic ecosystem. And there's clearly a $100 billion export opportunity as well. So I think it's a pretty large economic impact. And we've been all talking about, especially in the IESA community, we need a few anchor industries which are going to be kind of creating, a multi-fold ecosystem, the ESDM ecosystem that we talk about, from systems to chips to components to use cases to jobs and economic value addition, et cetera, et cetera. And 5G really can be one of those things, given the generational impact. And the fact that 5G networks will be very highly software differentiated, unlike the other stuff. So what China could do when hardware was really the game changer, they really created the Huawei's and ZTEs of the world. So when 5G is coming in and software is really where India is the sweet spot, what China was the manufacturing factory of the world, India is kind of the software factory of the world. So I think we have that as a sweet spot coming in. And I really think from a nationalistic perspective, a design and make in India pride for telecom industry is no different than the space mission, which we all feel very proud about. So I really think for all of these reasons, it's important to have self-reliance in telecom. Next slide, please. Second, 5G. What are the use cases for India? Do we need 5G today? When do we really need 5G? And why do we need really 5G? So I think first and foremost, on the left-hand side of the picture, I tried to capture a few India-specific use cases. Many use cases which may be very interesting and important for the rest of the world may not necessarily be for India. If I were to look at precision agriculture, farming, it's still a large part of our economy. We can play a good stuff there. Delivery services, especially in remote areas, again, a lot of opportunities. Rural broadband, our Prime Minister talked about 6 lakh villages, but beyond 6 lakh villages, there'll be a lot of pockets to be filled in between. Automated industry, assisted driving rather than self-driving, and of course, a lot of private networks of different kinds. So I think there are enough use cases, but I don't think any of these use cases is such a big killer app that we need 5G today. And what we really need in the country today is a more robust 4G that can enable a lot of critical services that are needed for the next 24, 36 months. We don't yet have a good 4G network because the fiber connectivity is not deep enough, is not rich enough. Still less than 25% of the cell towers are connected to optical fiber, and without a good backhaul or front haul, as we call it in 5G, there is no 5G. So the infrastructure element is completely missing, and it does take time to wire up all the base stations in a majority way. And even the home broadband connectivity today is far, far, far more relevant and important than anything else. So I think just getting the basics right in terms of having the ecosystem and infrastructure ready is important. And then we need to fine-tune the use cases for India so that they just don't become a glam use case, they become a good business case. Because India is a country where we have a very high value for money concept. So customers won't pay for something if it's not useful. operators won't spend money on something unless it gives them a good business. So I think we need to fine tune all of this. Given where we are in the state of industry, the maturity of the industry, maturity of infrastructure, I believe at least we are 2 years away from 5G. And that's actually adequate time for India to think of what and how we should do our own 5G. Next slide, please. Coming to the third question. Do we have strong domestic capabilities for 5G in the country or a telecom ecosystem as a broader problem? And I think 5G is just a prop, if I were to say, that we were to use. And I think there are a lot of people say a lot of things. I think I have worked in the US for many years. I've worked in India for the last now 20, 22 years. I don't think we should be diffident in saying that we as a country have enough people and we have enough talented people to build whatever technology needs to be built in 5G or 6G or 7G or whatever. The challenge for our country has been is an ecosystem which wants such companies and desires such companies to come out. The challenge has been we build stuff, but if the sales don't happen, if you can't scale up your business, the entrepreneurs are not going to go after this. If I were to look at the left side of the picture, of course, at the top of the pyramid, telecom services, we have world-class operators. We are the second largest market in the world. So that's a green. Management software, operation management skill set, use cases, green, no problems. The radio architecture ran, cross-all optical transmission like what Tejas does, and we've also, by the way, now built up our own radios for doing a wireless rollout. The core software, the devices, all that stuff can be done. System design, testing, EMS, manufacturing, no problems. Hardware, software protocols. I think we really have a lot of the greens in place, right? What is, I would say, yellows or orange or red, I mean, depending on which site you look at. We still need to crack the code on the standard essential patents, which will be required for building an end-to-end 5G ecosystem, and government has to play a very important role to make that happen. We need to have access to good fabs. The whole world is now changing geopolitically. So the alignment that we have with the US is a good thing because all the fab equipment comes from US. So I think that's not an issue. Fabless semiconductor design expertise is abundant in India. Probably half of world chips, half of the chips designed in the world touch Bangalore for some reason or the other. And probably half of the world's 5G systems also touch Bangalore and Gurgaon in some way or the other. So I think we have all that ecosystem. Market access in terms of how to scale up companies from India, how to scale up the businesses from India is something which we require. And we need optimal amount of funding. The venture capitalists, private equities don't fund if you don't have success stories. Government has to play a role in certain kind of bootstrapping systems. No industry in our economy has actually happened without government support. So even though IT industry, which is one of our big success stories, we say happened despite government, is actually factually incorrect because government probably gave more than $100 billion of tax subsidies over the years to that industry as well. So I think it will be foolish to assume that we can create an industry which requires billions of dollars of investment without any proactive government support and funding. And that comes to the next slide, and which is the last slide of my presentation, is how do we execute this whole thing? So number one, I think active government support is a must. We really need to work in a mission mode. And I think that 24 months is, if you take T equal to 0, within 24 months, you can create a 5G ecosystem, starting with 4G today. And I'm very happy to say that the Atmanirbhar Bharat clarion call that the Prime Minister has given, the bunch of announcements which have happened in the last, I would say, 60 to 90 days, are essentially telling us that the government is serious. They want to jump and make this happen. We need to get market access to get economies of scale. We need to secure the patents as a part of license condition. Aruna ma'am, when she was the chairman of the Digital Commission, did flag out this issue that as a part of the 5G license condition, we need to secure this aspect. Export promotion, there's nothing like an Indian market. We got to go after the global markets. R&D funding, we can think of a creative way that the R&D funding can be given to private industry, not as a grant, not as a loan, not as a freebie, but in the form of assured business. I'm sure startups and entrepreneurs would appreciate that. Nobody wants anything free, but we really want business, and I think that the government can secure. And then, of course, standardization. I think that's a game we cannot afford to lose out. I'm very happy that NAVEC and few other things, have been come out of the LMLC mode of 5G standards, 3GPP. India has fought the right battles. Second, I think we should not try to do everything for everybody in the world for 5G. It's a very large problem. pick and choose the battles that you want to fight and build an entire ecosystem around that to begin with in the next 24 months. And then, of course, we can expand it. Third, in terms of focus, start a system design approach with the available components, the ASSPs, create end-to-end solutions, all the software elements, network security, and then in parallel, pick a few high-impact areas and trigger fabless chip design for such components. The ISA conference, the community that I'm intimately aware with, is absolutely capable of delivering whatever chips are the highest impact chips, whether it's in the devices, whether it's in the optics, whether it's in the RAN side of things, or the DSPs. I think we have enough capability. And I think as a country, the way we have worked, an ecosystem approach is needed. We got to divide and conquer the problem. Large IT companies and telcos should become the anchors. The Jio's announcement around 5G is a very welcome sign that the telcos are willing to step up. If you would have been reading the press, TCS, Tech Mahindra kind of company saying, okay, we're going to pick up the gauntlet and put together the end-to-end ecosystem. I think this gives a lot of confidence that as an ecosystem, the country can step up very quickly. And the best-in-class products will come from individual companies, startups, and I think those need to be nurtured. And really, the Indian chips, once we get ready, can easily replace the components. So I think it's a very simple recipe. I've tried to simplify what needs to get done, but it's a doable strategy. And this is really where I will pause. But I can really kind of, on summary, say that we got to do it, we can do it, and we should do it. And I was telling someone yesterday, Aruna ma'am, to be honest, abhi nahi to kabhi nahi is really the way we need to think about. Thanks.
Thanks, Sanjay. I think your summary statement, abhi nahi to kabhi nahi, I think that is the real message that needs to go out to the entire ecosystem. So thank you, Sanjay. And with that, let me hand over to Parag. We already heard about, Parag being a serial entrepreneur and what he's, endeavoring to do. So over to you, Parag.
Thank you. It's always a pleasure interacting with you. Always a tough one to follow Sanjay. Always, he's such a good speaker, and he lucidly points out all the problems and succinctly gives solutions to them. The 5G is actually the proverbial the proverbial elephant, and we are all blind when looking at the different aspects of it. So I'll be focusing mostly my talk on the radio access networks, which form actually 50% of the capex of a network and are probably one of the most difficult parts of the 5G network, or any radio access network for that matter. So with that, next slide, please. Just a brief history of where wireless designs, RAN designs have been so far. Fundamentally, in the last 25 years, we have always looked at spectral efficiency axis only. The Shannon limit was one of the most ones, and that's been breached. And then with MIMO and massive MIMO, you're even sidestepping Shannon, and you're getting better capacity. So we have reached, I think, the peak of what you can achieve from a spectral efficiency perspective. In fact, even in 6G, and 5G and 6G, the maximum benefits that you have for throughput is larger bandwidths, right? Now it's time that we focused on other aspects of radio access networks, basically the architectures, and there are other patterns in the network that I'll describe later that are equally important than the spectral efficiency. So the other important aspect of RAN design so far have been, static provisioning and architectures. So the radio environment, if you look at it, is essentially dynamic. It changes every second or every 20 milliseconds, depending on whether you're moving or whether you're static. Generally, very dynamic. But all 3GPP standards so far have always focused on worst case scenarios, where everybody is moving at a certain speed, worst case speed, everybody sees a bad channel, and all schemes, all architectures are designed for that, right? The third important aspect is basically most networks are closed, so they are, I would say, quasi-open. The standards are open, but the implementations are very proprietary so far, right? And that leads to a lot of issues. And network operators all over the world have this problem that they are not able to mix and match and get an optimal juice out of the network when they mix and match vendors. And So far, network providers have been, vendors have been completely end-to-end. They are if you see, there are companies that do all the way from the core to the RAN and the services and deployment. So that's been the problem, and that is actually kind of in some sense limited innovation. The other aspect is, there's been little or no sharing of spectrum, or both from a regulatory perspective and from technology. So of late, I will talk also about that. How we are now in the fourth generation of sharing, right? Dynamic spectrum sharing, and spectrum being a scarce resource, I think we need to have more dynamic access mechanisms to the spectrum. And if you take an analogy to the road, today, Airtel has its own road, Jio has its own road, each operator has his own road. And if there's traffic on one road, on one pole, and there's no traffic on the other one, you can't just move them just because of regulatory. Earlier it was technology, now also because of regulatory restrictions. And most networks so far have always operated in what I call the interference-free regime. That's also led to the scarcity of spectrum. Earlier, we didn't have, signal, or we did have signal processing mechanisms, but we didn't have processing power to implement some of them. So therefore, you always had these dark bands. You had, very little sharing of spectrum between operators and between different systems and between radio access networks. Next slide, please. So how is 5G different? Again, I'm going to give this, again, this structure of this talk is more inside out. So Sanjay and Rajesh spoke about the outside in approach, where, you talk about use cases and all of that. I'm looking at it from a network provider's perspective, and also what opportunities that we are going to give. So 5G is a first baby step towards giving architecture of a network at the RAN level and at the core level its due importance. And Rajesh touched upon the fact that we got to move away from legacy to more dynamic and cloud-style architectures, right? So that's what is the most important. For the first time in our existence, 13 years that we have been around, people looked at us, derisively, right? We were a telecom company and a semiconductor company at that. You couldn't be worse than that, believe me, until 6 months back. In the last 6 months, because of the geopolitics, being a telecom company and being a semiconductor company is now the fashion of the day, right? So the bell bottoms are back again. From the 70s, now we are back. We're wearing the bell bottoms. So it's strange that how things can change in the 3 years. So the entire ecosystem is getting upended, especially on the infrastructure side. The device side is still mature, and I'm sure in the coming years, and we'll be party to it. Also disrupt that. There are a lot of greenfield operators who are now looking at building IT-like networks. Right? If you look at it from a network perspective, the three important aspects, or rather the two important aspects that are changing the entire the entire discourse on 5G is virtualization. That's basically running more and more components on standard programmable hardware, and I'll talk about the opportunities for semiconductor companies there. And disaggregation. I think that by far probably is going to upend the ecosystem like never before. So operators are now looking at slicing and dicing components and procuring, components like a Lego network from different companies and building them up together. If you want to do that, fundamentally the network has to be open, right? And
Looks like we lost Parag. Aruna?
Yeah, looks like we lost the feed from Parag. Parag, can you hear us? It's a connectivity issue.
hello, sorry, I missed out.
Yeah, you are back, Parag. We can hear you. Go ahead.
Okay. This one point that I disagree with Sanjay, while we should be focused on building existing 4G and all of that, if you want to build patents, you have to look at 6G, right? So here in India, I believe that we should start looking at 6G and various aspects of it right from now, so that we can build enough patent portfolio to be able to contribute to the 3GPP telecom ecosystem. So what is my own view of what's going to be beyond 5G? there are three important aspects that I am looking at. I touched upon the first one already, that we have to move from static to dynamic regime, right? Where the radio environment is dynamic to adapt. So I think Rajesh spoke about adaptation at a different level. I'm talking about adaptation at the RF level. You couldn't do that 15 years ago because you didn't have enough compute power. You could do a lot of those things today. The regulatory aspects also have to move in pace with the technology to be able to allow this dynamic aspect of the network. From quasi-open, so-called oligopoly, though 3GPP is it's a controversial statement, but I'll make it. Though 3GPP is open, it is actually a oligopoly. It's controlled by a few companies. But now with there are new initiatives from operators, and the control is with the vendors, by the way. So in 5G, the control is ceding from the vendors to the operators, where it should actually be, right? The operator should decide at some point in time when he should put in a refresh cycle. Like Sanjay also said, too often we are looking at 5G from a bragging perspective, where you can get, we can raise monies or we can look check in front of investors and customers. Right? So there has to be a use case, and that would actually mean a truly democratic process. I think in India we have shown through the Aadhaar stack or the India stack that we could build stacks which are open and which create level playing field for everybody. Right? That's revolutionized the fintech industry in India. I believe in India we should also look at building neither the Chinese model nor the American model, but the Indian model around the India stack model, where we have the India Telecom stack, based on bunch of open software frameworks and a whole bunch of startups that actually build semiconductors and silicon for it. And the third aspect basically is also horses for courses approach, right? So traditionally, the broadcast network, the satellite network, and the cellular network, they have operated in silos. They have their own set of requirements, own set of customers. So that silo has to be broken, and that will be broken more towards Rajesh called it the convergent networks. I go one step further and call it a liquid network, which is like water, right? Which actually changes its attribute based on use cases, based on traffic conditions, based on user functions, based on network operators' choice, a whole bunch of other things. Next slide, please. I'll very quickly. There's a lot of details that I can get into this, but very quickly, I believe my view of the world. I'm one of the blind men. For me, 6G is going to be all about going from static to dynamic regimes. It means the network designs itself, right, based on the environment around it, right from the RF level. And today, if you look at it, because of static provisioning and because of worst case provisioning, there's a lot of wastage of network resources, which is just lost. I don't have an exact study, but qualitatively, I have a gut feel that about 20 to 25% of the network resources are suboptimally used. So imagine if that 20% comes back, it's huge, right? And the other important part is that the 5G pipe, the unicast pipe, has become like it's carrying all kinds of traffic, right? There's this movies in the 80s where Satish, I just don't remember the name, where he used to say that gutter ka foreign mein gutter ka pipe alag hota hai, pani peene ka pipe alag hota hai, iska pipe alag hota hai. So we need different pipes. So, for example, Rajesh said that video, you can't carry video on unicast networks, right? It just chokes. So Hotstar claims that they have 18 million or 20 million subscribers, and that actually kills our networks. So we need to build environment-aware and payload-aware radio access networks and the networks. Of course, 5G has already a concept called slicing that allows you to do that, but that needs to be carried down all the way to the physical layer. And the most important aspect also I touched upon is the dynamic spectrum allocation policies. So sharing is currently the third generation. If you look at it, first sharing unlicensed concept was the Wi-Fi. Then the second generation was TV white spaces through static databases. You had an arbitration. 3G is with CBRS in the US, and unfortunately in India, other than we're still in 1G, we've not gone to even 2G, right? Because of a lot of other political and commercial reasons. Eventually, I believe the 4G of sharing would be where the network itself cooperates with the rest of the entities, other networks within itself and outside it to build, a very optimal network. And of course, most importantly, financial models, and especially for spectrum sharing, for spectrum selling. Spectrum is the oxygen of the digital infrastructure. So this is not my word. This is ex-Vodafone CEO's statement. So, and as a democratic country, it's the birthright of every citizen to want to have that spectrum. So we have to have different forms of spectrum sharing. Is what I believe in going forward. Next slide, please. I again touched upon some of this. We have to go away. The crux of this slide is that we have to go away from this patent royalty type of scheme to Linux-like licensing models. Open models where open is not necessarily free. Right? Red Hat built a very successful business. Today, all we are talking about cloud, we are talking about virtualization, we are talking about hypervisors, because in the early 90s, somebody decided that they want to build an open operating system. So we need something similar on the on the radio access network and other parts of the network. That's the important thing, and that's how we are going to get innovation. Otherwise, it would be a oligopoly with a few people controlling the the entire network. 5G is already doing that. There's a marriage between the the modulation standard, the 3GPP, and the architecture through an organization called Open RAM or ORAM, and that's a baby step towards defining a new ecosystem. And my own belief is that you have to look at virtualizing the interface and not the implementation. So think of the kind of monies that are required to build a device modem. Right? That's the reason very few people can actually go and build a 5G modem. It takes billions of dollars. Well, in India, maybe not $1 billion, maybe at least about $150 million to build a 5G device chipset. Now, the entry barrier to build that is very high. And that's one of the reasons why innovations are throttled there. If you look at in 95 and before 95, software application development was also the same problem. So you had, when you built a software, you had to deploy it on different flavors of Unix. You had Apple, you had flavors of Windows. So this whole thing of DevOps thing came in. Before that, you had Java. Java actually revolutionized the software application development, because it abstracted out the hardware on which the application ran. So we need something similar that abstracts out the hardware, that abstracts out the semiconductors underneath it, and have any kind of software run as a native portable application. Next slide, please. So what does all this have got to do with semiconductors? What is the semiconductor in the 5G era from a 5G perspective? I believe that, like I said in the beginning of my presentation, it's never been more fashionable to be a telecom semiconductor company, right? In the last 6 months. So there's a tailwind of the politics that's coming in, because everybody's realized that we don't have semiconductors. Oh, everybody's building online kirana stores, and they're getting all these $1 billion valuations, selling all kinds of things on the internet. But what about the innovation that feeds all of that, right? Those business models have to be fed by a technology model, and those are not existing. And now suddenly there's a spike in interest. So innovation is moving in semiconductors for me, especially, that's my opinion, from the consumer to enterprise. Because in the consumer domain, to build a modem, there are only 4 or 5 phone vendors in the world, right? And if you choose one of them, you're done. And to break into that is very difficult. And there's still no level playing field there. That's the reason Oran is providing us rather, the semiconductor startup that break to get into the 5G world. Again, dynamic sharing and analysis bands will drive a whole set of new architectures. Scaling, especially, we have so much compute power at 7 nanometer, 15 to 14 and 16, and going down to 7 and 3, that it'll give rise to programmable architectures. Though Moore's law is actually kind of tapered out. We believe this custom architectures will actually, like we have this Shannon limit that's been breached. We have also reached Moore's law in some aspects. But a corollary of Moore's law is now getting into play. I believe that every 5 years, your level of abstraction increases. Right? Once your level of abstraction increases, you can do more. And that's where we should all be focusing on. And architectures that enable virtualization, stuff like virtual RANs, are going to go forward, because especially in the 5G infrastructure side, the system architecture is kind of standardized around the cloud or the data center architecture, which is very pretty standard. Server blades with a control processor and a whole bunch of accelerators connected by a very intelligent fabric and by a bunch of software frameworks that actually are standard, so that people can go build different sets of. Next slide, please, and the last one. Next slide, please. Yeah. So, what's the future of semiconductors in this? Again, my perspective, and I'm in good company here. We coined this term application-specific architectures or application-specific DSPs about 10 years ago. I saw a talk by Professor Patterson and NEC about a week back, and they're talking about exactly the same thing. They're calling it the domain-specific architectures. See, architectures which are customized for particular domains, with the problem statement with the problem statement as a first-class citizen than semiconductor architectures. The old technique of just SoC integration, where I put more and more stuff inside, is kind of peaked out. That needs a lot of money, and that can be done only by the big boys. We can't do it. We can't do it as startups. Most hardware functions would get implemented in software, and we were called crazy 12 years back when we came up with the concept of software-defined radios. They literally called us madmen. We had all kinds of problems, and now suddenly everything software-defined is becoming the flavor of the season. Semiconductors is going to get platform-driven, like I said. Unfortunately, it is not about integration. It's not about horizontal skills. You need to have vertical skills, and VLSI skills are actually a given right now. And if you look at the AI workload, if you have looked at the semiconductor funding scene, especially in the US in the last 1 year, there have been a lot of AI startups that have got funding. And that's why did that happen? Because in AI, they've come up with these standard software frameworks, and that allows anybody to abstract out the hardware and still put it into your in the system. If you don't do that, selling a proprietary architecture in this is going to be very difficult. And finally, there is this connection between software frameworks, compilers, and VLSI architectures that is going to drive the semiconductor industry in the future. That's my thank you. I'm done, Aruna.
You're on mute, Aruna.
Yeah, thank you, Parag, for that very comprehensive presentation. I would have liked to have a small round of question answers, but I'm told by the organizers that we're running a little short on time because the next session is due to start. So maybe I think I will restrict the round of question answers. We'll throw it open to the audience and probably just take 2 or 3 questions. I apologize for that because of the constraint in time. If there's anybody who has any question for either Sanjay, Rajesh, or Parag, I'd request you to keep it very brief. And as I said, we can only go through 2 or 3 questions.
Okay, I see one question. Thanks, ma'am. And first of all, thank you all for driving such a fantastic panel and talking about the communication and next what's coming next. So I see one question from audience side came that we are talking about 5G, we are talking about 6G. What about the rural India? We don't have a NB-IoT or CAT-M1 kind of network which is low cost and serving the rural India. What's your thought on the same?
Who would like to take that question? Sanjay?
Sure, yeah, I can take it. So basically, as I had actually mentioned briefly that 5G is definitely going to be one of the use cases for 5G would be the connectivity in rural India. There's a standard in 5G called LMLC, Low Mobility Large Coverage, which was actually driven by India. So the LMLC standard is something which can be used in the 5G to give a larger rural connectivity. Secondly, as I mentioned earlier, and at the cost of repeating, I would say that there still is a lot of need for a better infrastructure within the country, both in urban as well as rural, which is what I said. We just need a better 4G slash fiber infrastructure in the country before we can even do 5G, because implementation would be otherwise impractical. Aruna ma'am, you may want to add something to that.
Yeah, I think, as was mentioned by Sanjay and as has been rightly raised in the question, I think, what is absolutely imperative is that, we need to ensure that the rural rollout of the national optic fiber network is completed at the earliest. It's already fairly delayed, but fortunately, we heard from the Prime Minister at the Independence Day address that this is going to be one of the priorities. We're talking now about digital education. All schools are closed. Children don't go to school. All of them are actually now, moving into the mode of digital or tele-education. The government is already talking about the digital vaccine mission, where they will deliver vaccines and monitor it, remotely. So all of this is only underlining the fact that, whatever the government and the private sector telco operators can do to make sure that rural India gets connected fast, that is the absolute need of the hour. Having said that, of course, even when the government drew up the 5G roadmap, it was very clearly stated as one of the first objectives that we should not have a 5G rollout scenario where we cherry pick the most premium urban areas and then leave the rural rollout for a few years hence. So hopefully these lessons will be taken on board as we go into planning the 5G rollout. Sumit, do we have time for one more question, or are we done here?
No, ma'am, actually, we are done here. We have already consumed quite a lot of time from the break also, and
Right.
we have to move on to the next session. So thank you, ma'am, and thanks rest of the panelists for a very engaging session, and thanks for sharing your views that how is the communication landscape is going to look like going forward and where is the future. With that, I would like to thank our panelists and our eminent speaker. First of all, the chair, Ms. Aruna Sundararajan, thanks for your time as well as driving this engaging session. Please give a big round of applause to Aruna, ma'am. Next, Sanjay, you were fabulous in talking about how is the network roadmap is going to be. Is that we are talking about wireless always, but there are a lot of other form of networks. So thanks a lot, Sanjay, for bringing your perspective, and it was really good for all of us. Rajesh, it was really good. Yesterday, Gary also spoke about the network scenario, and you also mentioned and emphasized on that the need. And thanks a lot for your engaged session and your points. Thanks a lot for spending time with us on this panel. Please give a big round of applause to Rajesh. And Parag, I think this was great to hear that the software-defined radio and how the first Indian fabless semiconductor company is driving a communication space, and all your views, vision, and very interestingly, you talked about the underutilized network and how we can improve it further. So thanks a lot, Parag, and big round of applause for Parag. With that, our day one session or day three session one is over, and we had a packed agenda, and you can see that we are running a little delayed. And I would recommend all of you to go and visit the EPS booth. You get to see that a lot of product getting showcased over here. Our next session, we are starting 15 minutes delayed because ideally we should be starting at 2, but we are starting 15 minutes delayed at 2:15. And we second half also, we are packed with a lot of great speakers. And there are so many sessions on security and many other forms. You can see the second half agenda over there. We have security session. We have views from Indian academia where IIT directors will be come and sharing their thoughts. We have the visionary talks on social side of it, and finally we'll conclude the day with one big initiative from India when one mobile company is trying to go big in the global world. So stay tuned. We'll be back at 2:15. Let's finish.